Quantum theory and pretty much everything in the idea of the universe. What is quantum theory? At some point you've probably heard of it. If you don't know what it is, I hope to change that. I'll begin by explaining the basics of what exactly quantum theory is and how it relates to the end of the universe. The Copenhagen interpretation of quantum theory revolves around the theory of how matter behaves when it's not being observed, when the state of an object is not known. We tend to assume that it is in one state or another. However, quantum mechanics tells us otherwise. If an object is not being observed, we have no way to prove that it is in a certain state without looking at it and measuring it, right? But just looking at something doesn't change it, right? Again, quantum mechanics tells us that's incorrect. The multiverse, or many worlds interpretation, states that our universe is only one of an infinite quantity. Every time an event occurs with numerous possible outcomes, our universe divides into a number of alternate universes equal to the number of potential outcomes, and each new universe contains a different outcome for this event. Because subatomic particles have been observed to move unpredictably, this means that the outcome is entirely random. Erwin Rudolf Joseph Alexander Schrödinger, yes, that's his actual name, was a Nobel Prize-winning physicist responsible for numerous theories regarding the behavior of subatomic particles and wavelengths. Additionally, he did extensive work in the unified field theory, in correspondence with Albert Einstein. Schrödinger lived from August 12th, 1887 to January 4th, 1961. But how does quantum theory apply to everyday life? This is all interesting and everything, but how does it matter? Probability. First of all, electrons are the only form of matter that have been observed to move completely randomly. But if I told you to pick a number at random, your response would be random, right? The answer to that is debatable. All events are determined by movement of electrons and transfer of energy from one object to another, which, as I've said, tends to occur randomly. All other movement that is determined by this, however, it is anything but random as shown by this graph. Both data sets exhibit a pattern which rather closely match each other, but certain numbers such as 7 or 17 are outliers, and consequently seem to be considered more random than others to humans. If you continue to test this, the results would begin to even out, but that's just distribution at work. Over time, everything begins to be distributed. Seriously, everything. End of the universe. Now here's the part where I get to talk about the end of the universe. Because energy is constantly being distributed, matter is always in motion. If you put a drop of food coloring into a glass of water, it will eventually color all the water regardless if you stir it. In the same way, scientists have theorized that all the energy in our universe will eventually become evenly distributed. When this happens, no subatomic movement can occur. Therefore, nothing can move. The universe will be the same temperature everywhere. Absolute zero. The coldest possible temperature. This is known as maximum entropy, or, ironically, the heat death. Fortunately, though, this will happen for about another 1 Google years. 1 Google is 10 to the 100th power. Put this in perspective, that's 1 followed by 100 zeros. But it's not all bad, right? This is what our night sky will look like in about 4 billion years when the Milky Way galaxy collides with the Andromeda galaxy. However, gravity will most likely tug the sun into a new orbit, dragging Earth and other planets with it. But even though the Milky Way and Andromeda each have over 100 billion stars, it is unlikely that many will meet. The fact that even the most crucial decisions can be reduced to sheer random chance is disconcerting and fairly frightening. I mean, the odds of you existing are estimated to be around 1 in 10 to the 2,685,000th power. Combine that with the off chance that humans evolved to have the theory of mind, and you're looking at some astronomically small odds. That's pretty much quantum theory.